welcome to Science Spectrum with Don. This is the third lecture in the Fundamentals of Physics with course code PHY 187. Now, in today's class, I will talk about measurements. We'll talk about measurement of physical quantities. Measurement of physical quantities. Physical quantities, and of course, to make measurements quantitatively, we use units. And of course, when we measure with a few of these instruments, we encounter some errors there. All right, so let's get started. We measure physical quantities in order to concretize our world. We have to be exact about things we measure. All right, so it has to be the same for everybody. So that's the more reason why we make measurements. And of course, you may attest to the fact that if you've transacted with a bank, and of course they sent you a message to tell you, thank you for banking with us, and a certain amount of money have been deducted from your account, and of course you have not a great deal of amount though. Of course, you wouldn't be comfortable with that. You would be interested in knowing how much was deducted from your account, and of course how much you have left. Why? Because when we concretize things, it makes our world even more fascinating and even beautiful. All right, now what is measurement? It is simply assigning unit values to physical quantities. So let's take for instance, if I told you that I measured the length of a book and I found out it was, let's say, 4 centimeters. Let's take for instance. Of course, this is reasonable. I have identified a numerical value, and of course, the unit is meter. It has a standard, and of course, this centi is just a prefix for a power of 10. So what's the unit? Basically, just a unique symbol we assign to different measures of physical quantities. But if I had told you that I measured a book and I discovered it is 4.0, of course it is utter nonsense. 4.0 of what? There has to be a reference standard in which the unit itself is defined. So when you make measurement against a reference standard. All right, so now let's take for instance that I have a scale. This is a scale, and of course let's say it's in millimeter, and I divide this into equal portions. You could think of this as your meter rule, so to speak, because the least mark there is in millimeter, is 1 millimeter. So let's start from this. Let's say this is a 0. So this is 0. This is 1, 2, 3 millimeters, 4 millimeters, 5 millimeters, 6, and of course the list could go on and on. So I'm interested in knowing, I do know that a measure of length is 4 millimeters. I know the true or actual value is 4 millimeters. This is just like the target. All right, but if you recall, or I could tell you that a unit value, what a mark represents here, we call that a unit value. A unit, I could say a unit measure for a unit measure. And of course, what is a unit measure? Just what one mark stands for. And of course, if you take the difference, you will know. So this is 1 millimeter, that is a unit measure. Now, it may interest you to know that I could make measurement to half of this. I could go pretty close to the actual value by a half of the unit measure. So what this simply implies is that half of the unit measure of the, before the actual value is this, and this is half of the unit measure. So half of that unit measure, we call that the probable error. And of course, that is a unit measure divided by 2. That's a unit measure is 1 millimeter, and of course I divide that by 2. I'll get 0.5 millimeter. So now, so this is how far I could go in order to measure the actual value. Now look at this. Let's take for instance that there are 3 persons. They start off from 0, and the first person measured this actual value. He wants to hit a target, and he figured out in this scale and found out that he came pretty close to the exact or the true value. This is person A. The other person came right on the spot, measured 4 millimeter. And the third person, person C, measured and exceeded the actual or true value just a little bit. Now, this is really telling you and I something interesting. The person A, B, and C would report their answers as 4 millimeter. Why? Because if you look at this, the half of the unit measure, which we call the probable error, this is the range in which we could figure this out. So, in other words, when you make measurements that is within the range of this error, what is an error? An error is simply the difference in the measured value minus the true value. And of course, we could see that for real. This is the difference in the measured and the true value. The difference is this, the difference is this. However, when you make measurements and it falls within the range, this range of errors, which is uniquely specified by half of a unit measure, definitely we have to report our measurements in terms of the range of these errors, which is, of course, 0.5 millimeter. So the question is this: how would the first, the second, and the third person report their answers? Of course, they both reported their answers as 4. They would report their answers as 4 millimeter. Why? It is simply because the measurement, their measured value, is within the range of errors. So what it simply tells us is that we have to take into account now. We have to take into account the probable error. So to make this reasonable, if the answer will be reported by each of this person and taking into account the range of errors in which the measured value falls within, then this will be 4 plus or minus 0.5 millimeter. And of course, I could be detailed with it. Since the probable error is for 1 decimal place, I could just say this is 4 plus or minus 0.5 millimeter. And of course, this is correct. Why? Because there is room for the range of errors that is encountered in this scale. All right, now the net effect of this error, we call that the uncertainty. So uncertainty is simply the net effect of this error. All right, now so what this simply implies is this: if the first person, if you tell me that you measured this actual value and you figured out it was 4.5 millimeter, it means it's correct, because 4.0 plus 0.5 millimeter will give you 4.5. And if you remove 0.5 millimeter from 4, definitely, so if you tell me 4.0 minus 0.5, definitely, and you tell me you measure 3.5 millimeter, of course it's also correct. Why? Because it is within the range of these errors. All right, now there are 2 key terms I would like to be detailed about. The first is precision. How precise could measured values be? And then how accurate could it be? So I'll talk about precision and accuracy. Precision and accuracy. Precision and accuracy. All right. Now, to explain this, I would explain this with what I call the dart analogy. The dart analogy. So just like we have a scale here, and of course we know what the actual value or the true value is, but we could report our answers. We could report our measured value within the range of errors. All right, so the dart analogy, you could think of this as a scale, just like you have here. And this is the target, which is the actual or the true value, like we have the 4 millimeter. Alright, the first person, let's say person A, measured and came pretty close to the true value. So this is person A, came very close. He shot, just like you read this on the scale now, and he measured and then he figured out his value was pretty close to this. So this is just the error. Then the second person comes in and figured out that he measured right on the target, person B. And of course, the last person, which is person C, found out that he shot his darts to the target, but it came right here, person C. So what is precision? It is how close. Of course, this experiment could be repeated. In other words, I could repeat this as often as I want. So what is simply precision? Precision is how close repeated measured values are to each other. That is precision. How close repeated measured values, the closeness of these measured values to each other or one another. That is precision. And what is accuracy? It is the closeness now of the measured value to the actual or the true value. So in other words, if you ask me which of this measured value is precise and which is accurate, I could tell you from here. Alright, now let me quickly define what precision and accuracy is. Precision, like I said earlier on, is how close precision is how close repeated measured values are to one another. That's precision. And of course, accuracy is how close measured values are to the true value, or we'll call that the actual value, just like we have before, and just the target here. Alright, now how do I really tell which of the measured values is more precise and which is more accurate? Now, precision is really the probable errors job. That is precision. The probable errors job will tell you how precise a measured value is when you compare them. And the accuracy is really the relative or the fractional errors job. So let's get to that shortly. Alright, now take for instance that time was measured with a stopwatch. And so this is the measured value for time, measured value. And of course, it was discovered that time with a stopwatch, the person who measured discovered, let's say it was 4.0 seconds. That was what he figured out. And the second person used, let's say, an electric counter and figured out that that same value he got is 4.12 seconds. Alright, now definitely a unit value or a unit measure we could tell this is to one decimal, this is 0.1, this is 0.1 second, and of course this is 0.01 second. Alright, now I could tell you what the probable error is. The probable error is just divide the unit measure by a half, or by a 2 rather. So when you divide this by 2, you get 0.05 second. And when you divide this, you get 0.005 second. Alright, now what is the relative error? We call it the relative or the fractional error. It is simply dividing the probable error by the measured value. Now, for the sake of time, I may need to pause here. But if you're new to the channel, you want to like, share, and subscribe for more content. Thank you.